Okay, good afternoon. I'd like to welcome Drew. How do you pronounce your last name?
Montreuil.
Montreuil.
Yep, it's
Okay,
just ignore the U and the I. Forget they're there.
Drew Montreuil, the brains behind FLX Weather. And in honor of Drew's being here, I'm wearing my favorite hat,
Very nice. I like
whether
it.
he's ever seen one of these or not. But in any case, I read his stuff every day or every day that it comes out. And it's the best weather. I don't watch any other commercial weather anymore. So, in any case, Drew, why don't you give us a little bit of background on yourself, how you got where you are, and then give the talk. Uh, we'll do a question and answer once you've gone through what you wanted to cover today.
Okay.
And take it away, Drew.
Okay. So I'm actually going to start the talk because I built all that kind of background and kind of the history right into the presentation today.
Perfect.
So let me just share the screen here. Okay. Just getting everything set up. Looks like the laser pointer works. Okay.
Yep.
So I'm going to talk about Finger Lakes weather then and now, kind of a brief history of how I got to where I've gotten today, and then some of the tools and things that I use to make my forecasts and how I do things. So it'll be a nice kind of background look for those of you who have been following me for a while, and it'll also be a nice overview if this is the first time you've heard of Finger Lakes weather. So a little bit of both. So start off a little bit about me. I am meteorologist Drew Montreuil, and I've been living here in the Finger Lakes in Groton since just shy of my third birthday. My parents moved up here from Pennsylvania, and I ended up eventually buying my parents' house, and so I'm still in my childhood home. It's just mine now. And ever since I've been up here, so pretty much as far back as I can remember, I've loved the weather and I've been a big nerd about it. Here I am with my older brother in the blizzard of '93. I was about 4 years old at the time, and I don't know if the blizzard of '93 was kind of a pivotal moment in shaping me and pursuing the weather. A lot of meteorologists kind of sometimes have that big event that triggered everything. But it's possible that that was kind of the start of everything that came after. So as I grew up, Groton's a small town and everybody knows everybody. And so by the time I got to high school, everybody knew I was interested in the weather and was, destined to be a weatherman. And every time there was a chance of a snow day, everybody in school would be like, "Hey, Drew, are we getting a snow day tomorrow?" And I would ask that like literally 100 times a day. And I finally got tired of it and said, I'm just going to make a website and put it up on there, and then people can go there, and then I don't have to answer the question all day, every day. And as I started to build that website, which was grotonweather.com, I quickly decided to put more than just a snow day forecast up there. And so this is a screenshot from a very early version of FLX weather, or Groton weather, sorry, where I have just a very basic forecast, short little paragraph discussing the weather, a couple little charts showing, thunderstorm chances, what the tropics are doing, and a bunch of links on the side to other people. So I was in, I think, 11th grade when I started this, and I had no idea when I started it that eventually this would lead to a full-time career doing this sort of thing. So it was definitely a foundational moment and a very pivotal moment in my journey to get to where I've been. After high school, I went to SUNY Oswego. We actually didn't get a lot of snow the 4 years I was there. We had like maybe 2 good lake effect snow events. This is one of them. These if you look at this tree, these pictures were taken about an hour or 2 apart. And you can see by the people all walking that, yes, we still had class, even though you couldn't see 10 feet in front of you hardly. But it blew out, and then it was a nice day. So, all the stories you hear about SUNY Oswego are generally true, just not so much in the 4 years I was there. couple of very important things happened when I was at SUNY Oswego. The first is one of my professors started an organization called the Lake Effect Snow Prediction and Research Center, or LESPARC. And initially, he brought me into LESPARC just to build him a website, since I had GrotonWeather.com and he had seen that and he liked it. And by the time I got to SUNY Oswego, I had upgraded it and it looked quite a bit nicer than that first screenshot that you saw from when I was in 11th grade. But eventually I became the lead forecaster for that organization. And what we would do is we had several schools and colleges around Lake Ontario that we were doing forecast consulting for. And so they would call us up at 3 o'clock in the morning and want to know where the lake effect snow bands are going to be and if they should close school for the day. And so that was kind of my first taste of being a private forecaster and doing consulting for companies. And I enjoyed that quite a bit. I also dabbled in the campus TV station, doing the weather for them. It was okay, but it didn't quite fuel my fire. I did an internship with the National Weather Service, and I liked the Weather Service, but they do a shift work schedule. So you'll work a week, normal daytime hours, and then you'll do the night shift for a week, and then you'll do kind of an in-between shift for a week, and then you'll get like 10 days off. And that just wasn't what I wanted. I wanted to get married and have a family, and I just didn't want to have that sort of rotating shift schedule. And so I kind of honed in on my experience with the consulting and said, oh, maybe there's something there with that. I also got to do 2 research projects on how the public perceives weather forecasts. And it was just kind of an on-campus study, but it gave me a lot of good information that I still have incorporated today into how I do the forecasting. And I also did a research project on tornadoes in New York, which is an interest area of mine. And I've started to do a little side research project now, kind of as a follow-up to that. But I won't get to talk about that too much today. So after Oswego, I went to Cornell and I did a 2-year master's program that took me 4 years. I was doing a research project on temperature variations over the vineyards in the Finger Lakes, and the research project just did not want to cooperate. The data didn't want to cooperate. And so what should have been a 2-year project ended up being almost 4 years. Basically, we had all these temperature sensors right out in the vines at different vineyards around Cayuga and Seneca Lake. Here's a plot showing different sensors at Fox Run Vineyards and Red Tail Ridge up on the north end of Seneca Lake. And so you can see, it's a little hard to see maybe depending on your screen size, but we had multiple sensors within a field and they were aligned kind of along the elevation lines so we could get temperature readings over different variations in the elevation. And from that, I was able to create different models to try to see where cold air is going to pool up. That's an example of this down here. This is a model showing how the cold air flows over the terrain. And so you get these cold channels, and we could see that in the data where we'd have 2 temperature sensors right near each other. And one would end up having really cold temperatures, one would be a lot warmer. And we discovered it was these cold channels that, just the little bumps and hills in the terrain and where the tree lines are, all had a big impact on that. So it was a really interesting project. Since it was scientific research, sometimes that gets frustrating, and I spent a lot longer on it than I wanted. But part of the process of this was running these big long programs. I mean, I would literally go in to work in the morning, type a few lines on the keyboard, start the program running, and it would take all day running through these millions of observations, tabulating them, doing what I want. So I would basically just sit there and not have anything else to do. And that's kind of where Finger Lakes weather started to grow out of Groton weather. It's in that, I would be watching the weather, and when there were big weather events, I'd start posting more on Facebook. And also I was, thinking, what am I going to do after I graduate, if I ever graduate? And so I started Finger Lakes weather. And initially I was really focused on getting clients, just like when I was working at SUNY Oswego. I wanted to do one-on-one forecasting for individual clients. So I had, some school districts that I was forecasting for, summer camps, I had a couple of media partners. The biggest one was the Syracuse.com. I was freelancing for them for several years. Farms, a mini golf course I was forecasting for. They had a little widget up on their website so that people could see when the weather was good to go mini golfing. But over time, there was kind of a shift as more and more people started following me on Facebook, that I was spending more and more time dealing with the public instead of my private clients. And that's kind of evolved into what I do today. So I'm an independent meteorologist. My company is just me. There's nobody else here. I do all my work myself, and I do quite a few different things now. I've got my blog post, which comes out almost every weekday and sometimes on the weekend, depending on how the weather is. So here's a little screenshot of today's post. I run a 7-day forecast graphic. I now have a mobile app, which takes a lot of the data from my website and feeds it in to the mobile app so that it's easier for people to get. I do live storm event updates, and I do talks like this. And so just a lot of different things to try to get people the information they need. And over time, kind of 3 core attributes have come out of all this: honesty, accuracy, and accessibility. And when you go on the Weather Channel, they don't really have core attributes that they put up there or anywhere else. So this is kind of something that I think is a bit unique to me, where I've identified these traits as the things that I really focus on, and everything I do kind of runs off of those. So honesty goes to kind of my calling card is the no hype weatherman, and I'll talk a little bit more about that in a little bit. But I'm very clear with what I know and what I don't know, and I communicate that to people so that they can understand the different scenarios. Accuracy, I feel like that was kind of a cheat. Every meteorologist strives to be accurate, but I do think that I have a leg up on a lot of the, especially the national services that are forecasting or just taking model data and feeding it into their website or their app. They don't understand the Finger Lakes and all the different microclimates and things, that I've been here and experienced and studied, and academia. So I feel like I do have a leg up on accuracy there, and people tell me that I do a good job, so I'll take that as well. And then accessibility. So everything, all my data, all my information is freely available. I don't have anything behind any paywalls or anything like that. And so how I make money off of this is people donate to me, and I do have a couple of local sponsors. And then I do have three media clients that I still do some weather work for as well. So I do still have a little bit of clientele, but mostly it's all focused on the public now. And everything, every year after year, there's a bit more growth. So far this year, I've had over 700,000 views on my website and my app. So a lot of people are using it, and a lot of people are very generously donating so that I'm able to do this pretty much full time now. So let's talk a little bit about some of the tools I use and some of the ideologies I've developed. There's been a lot of advances over the last 10, 15 years in some of the technology that meteorologists can get their hands on. One of them is the GO-16 satellite, which was launched towards the end of 2016, so about 6 years ago now. And this satellite gives us so much more detail, so much more information than the satellites prior to 2016 gave us. So just one application for this, satellites are up in space taking pictures of what's going on in different camera modes, and they can detect things like lightning and forest fires, and in this case, fog. So the old satellite gave us a view kind of like this. It's just, there's a little bit of fog here down towards Binghamton, but it's really kind of spotty and sporadic. And so it's like, okay, is this just noise, or is this actually real data coming in? And it's okay, but it's not terribly useful, especially compared to what we have now. So now if you take this data and apply the new satellite's algorithms to it, start to get a better picture of the fog. You can see in the river valleys in the southern tier in northern Pennsylvania. But now you take the new satellite with the new algorithm, and you can really scaled down real fine to see where these foggy areas are. And if you've ever driven down in the southern tier, from Cortland to Binghamton in the late summer, you'll know that the fog can be very intense, but very, very localized. And so it really shows up nicely on the new satellites. Another huge upgrade was to the radar network, which the National Weather Service has control of, and it's called dual polarization radar. So radar used to just send out an energy beam with a horizontal wavelength. Now it sends out both a horizontal and a vertical wavelength, and that lets us get a three-dimensional view of the particles that these energy beams are bouncing off of. And that allows us to determine, is this a raindrop or a hailstone or a snowflake, or is it a bird or bugs? Those things can get picked up by radar. So it gives a lot of good information to that. But then some of the algorithms, I guess you could say, that they've applied to this data just really has been extremely helpful, especially in tornado detection. I think tornado detection was probably one of the main things that got them to do this upgrade. So we've got 4 panels. These are all the same data, just showing in different ways. This first panel is what you'll see if you turn on the TV and check the radar, or go on my website and check the radar. The brighter colors are showing heavier precipitation. And when you're trained, you can kind of tell some things from that. Like I can see there's a little bit of a hook shape to these higher colors, brighter colors here. So that could indicate that there's some rotation in the storm. If we look over here, this is showing what way the particles are blowing relative to the radar. So the green colors are blowing towards the radar, the red colors are blowing away from the radar, and we got these bright colors right next to each other. So you can imagine if you put like a pinwheel right in the middle there, that it would start spinning because the winds are pushing it 2 different directions. And this has always been available on the radar as well. This was on the old radars. And so that's a good indicator that this storm is strongly rotating. But the problem is that there's actually quite a few thunderstorms that rotate, and trying to figure out which ones are just rotating strongly and which ones have a tornado on the ground, was a major obstacle. So these 2 modes are 2 of the new modes, and they're complicated and there's a lot of math and all sorts of stuff that goes into them. But basically the ZDR here is a ratio of how long to how tall the particles are, and the CC is the correlation coefficient. That's how similar the particles are to one another. And so where we see this kind of hole in the ZDR coinciding with this hole in the correlation coefficient, this is telling us that there are debris of all sorts of shapes and sizes and lengths, and everything is different, which means it's probably debris from a tornado that the radar is picking up. And so that's a huge hint to the National Weather Service that, yes, there's a tornado on the ground here, so they need to issue a tornado warning for it right away. So I have no doubt that this technology, everything else staying the same, this technology has saved many, many lives already. Here locally, this is the New York State Mesonet. It's a few years old now. It is a series of sensors. There's at least 1 in every county, and it's just a basic temperature, humidity, wind direction, precipitation network. But it's really important because before this network was in place, I could see data from Cortland, Ithaca, Binghamton, Elmira, Penn Yan, Rochester, Dansville, Syracuse. There's a lot of gaps in that coverage from the previous network. And those stations are still there, so I can still get that data. But now I've got this extra set of data to try to nail down even closer to what's going on across the region, since things vary so much. So that's been a huge help. I would love to have, a network that's 10 times as dense as this, but I'll take what I can get to start. Weather models, you hear a lot about weather models from different meteorologists on TV and on the internet. I kind of have a bit of a love-hate relationship with the weather models because they're obviously a humongous tool and they're very good. but they're very tempting, and a lot of meteorologists just run to the models and take the computer, it's just a computer program that's running what it thinks the weather is going to do. And they just take that as the gospel truth, and they forget all the science and all the experience, and leave that part out of their forecasts, and the forecasts suffer as a result. I still think that human meteorologists can outperform the models, and there's lots of different models. They have different strengths and weaknesses. I just got done during September doing a little bit of a study with a few of the major models. I would look at the forecasted high temperature and the forecast low temperature for Ithaca on these models, and I would compare it to what actually happened. And I learned a bit more about the models and have adjusted the way I forecast slightly, to try to get better based on that. So you always have to be looking at the trends in the models and how they're doing and where they're good and where they're not. And the science of meteorology is, it follows the scientific method. You make a hypothesis, that's your forecast, but then you have to go back and see how it actually did. And that's the step that a lot of meteorologists miss. Here's another look at the models. So in this view, they take the same model, they tweak it slightly and run it 50 different times each time. So this gives kind of an overview of what's possible. Sometimes all these end up being wrong. Most of the time, at least some of them end up being right. But I use this a lot in the winter when people say, hey, I heard we're going to get a snowstorm in 10 days. And I'll go and look and say, yeah, 1 out of 50 says we'll get 14 inches of snow, but everything else says nothing. So probably not something to worry about. Speaking of snowstorms, they are the #1 source of weather hype, probably. Everybody wants to know what the weather's going to do in the winter when the storm is threatening. This is a look at, I don't remember what year it is, but just weekly views on my website from November through April. And you can very easily pick out that we got snowstorm the week of January 10th, right at the end of January, and a couple of minor events in February and March, because I had so much more web traffic on those days than others. So people really want the information, and unfortunately, a lot of media and online personalities take advantage of that. And anytime there's the slightest little threat of something, they'll blow it up into something huge so that they can get lots of people clicking on their website and liking their page and stuff like that. So here's my favorite example, one of my favorite examples of weather hype. This is from 2014, so it's pretty old now at this point. I found this on Facebook from northeastusweather.com. And this was February 24th, and they were talking about a storm in the first week of March, whenever that actually is. So about 7 to 14 days out, somewhere in there. And they've got the entire northeastern quadrant of the United States shaded in this nice, alarming red color. Significant storms to affect 100 million plus people, heavy snow, heavy ice, severe weather, flooding. And the quote that I picked out is, much of the eastern United States is under the gun for this storm system. I would not be surprised if there's a huge swath of 10 plus inches of snow and a decent ice event or ice storm of over a ½ inch of ice, which is pretty significant. And they were also calling for a whole bunch of severe weather and tornadoes across the southeast. And so I saved that and said, okay, I'll wait 10 days and see what actually happens. So a little storm system did come through, and a couple places managed to just get to 10 inches in Indiana and West Virginia, but mostly, 2, 3, 4, 5 inches. So not really a huge deal. Nothing at all up in New York State and New England. No severe weather, no flooding, no icing. So this Facebook page, caused all this alarm for 100+ million people, pretty much for nothing. And so that's the sort of thing that I try to combat and not do. Instead, I tend to hold off on making a snow map for an event until the last possible minute. And it's a very fine line between giving people enough heads up and having enough information to make a good forecast. And I never know where that line is exactly for a given storm and event. So I try to do my best. Sometimes people wish I put out a map a little sooner. But I try to always explain the reasoning behind what I do. So here's an example from last January, where we had one of those messy storm systems come in where the sleet and rain might mix in and cause the snow to not accumulate as much as other times. And it's always, razor thin difference between getting a foot of snow and getting 4 inches of snow. And so I highlighted that the area I thought that line would set up and said, this is where I'm the most uncertain. I've got a low confidence in this overall to begin with. And I said, these people, if you're in this area, you might get this, but be prepared for this. And people were. And, there have been times where, I've done this sort of thing and the final snow map doesn't look anything like what I forecast, but people don't come after me. It's the internet. It's supposed to be full of nasty comments and stuff, but people don't really do that. And so that's how I try to do things so that they can understand what's going on, and people appreciate that and seem to like it. I'll just kind of blitz through this real quick. Another thing I don't do is put a percentage on the probability of rain or snow. What exactly is a 30% chance? It has a very specific technical definition, but people get confused by it all the time. So I say what it's going to do. Occasional rain showers, mostly after 8 p.m., then drizzle and some fog. That'll give people what they actually need to know instead of saying, yeah, there's a 30% chance of rain. I also, right on my website, have my forecast confidence and tell them what the other possibility is. And I think for my forecast for tomorrow morning, I think I put the forecast confidence at medium high, and it's right there on my site. And it says, if the clouds clear out sooner, it might be colder than forecast. So people can know that. People love this slide, and I can't take credit for this, but I found it. It's finally a way that I can easily explain the difference between a watch and a warning, because people get confused by this all the time. And when I did my research at Oswego, even meteorology majors were confused by this. So a watch means that all the ingredients are there on the table. So if we have a severe thunderstorm watch, it means the atmosphere is ready to produce severe thunderstorms. Are all the ingredients coming together yet? Not necessarily. If they do come all together, then you get your warning. So all your taco ingredients are there. It's a taco watch. Put them all together and you have a taco. That's a taco warning. There's also advisories, which are kind of an in-between. They're for when the weather is bad, but not quite bad enough to be a warning. An example of this is the frost advisories that we've had a couple of times over the last few days. It means, a frost advisory is, there's going to be areas where sensitive plants get damaged, but it's not as bad as a freeze warning, which means, the plants are going to die. So that's kind of the hierarchy as I see it between watches, advisories, and warnings. And all these are issued by the National Weather Service. You've seen them probably scroll across the bottom of your screen on the TV. Your phones buzz with them now. So lots of different ways to get those watches, warnings, and advisories. And hopefully it's a little clearer now what's what. So mobile and social weather, this has been a huge advancement, and definitely not anything I saw coming when I started in 2006. Social media has just been a huge influencer on how everybody gets information, but that applies to weather too. Everybody talks about the weather, and social media is a great way that I can interact with people and be accessible to them and build that trust and relationship with people. Unfortunately, like I said, social media can also be a big highway for hype. So there's pluses and minuses to it. Facebook Messenger has been something that I have heavily used, and it's been a real great tool. It allows me to communicate one-on-one with people, especially in the winter. People are always asking me, I have to go to a doctor's appointment in Rochester, is the snow going to impact me? And, I can help them through that. And I never tell them what to do because I don't want to be liable for their decisions, but I give them that extra personalized information so that they can make the best choices that they think they can. And, this is really where the accessibility comes in, because I'm accessible to them one-on-one as like a personal meteorologist. And, you can't call up the weather service or the TV station or the Weather Channel and get that sort of attention. So that's something I really enjoy doing. Social media is a two-way street, though. I get a lot of good information from people as well, especially here in the Finger Lakes, where it can be so different, over real short areas. And this is one of my favorite exchanges over the course of less than an hour. This person said there was steady rain in Newfield. This person just 6 miles south had heavy snow, and then the original person changed over to snow, and they let me know this so I could, verify what I was seeing on the radar and with the reports. And so it's a real good tool for me as well to get that extra information. The more information I have, the better I can do my job. In the summertime, especially, I've started doing live storm updates. So it's like a live blog where I'm posting, different graphics and explaining them, posting the latest warnings, and people can ask me questions on there as well. So that's been a real good tool that I've started to use in the changing by the minute severe weather events. And that's all right on my website and in the app as well. And then the app itself, it's a little over a year old now, I think. And it's just another way for people to get the information they need and for me to do all the things I need to do. And like I said, it pulls a lot of the information from the website, but it displays it a little bit differently. And there are a couple of different features on there. And that is both Android and Apple free, like everything I do. So you can get that if you'd like. Okay, that's all I've got. And I am 2 seconds under 30 minutes. So
Thank you.
I could talk for an hour about for hours about the weather. I do have a little feedback survey. If you want, you can scan the code, or I'll drop this link in the chat in a minute. Just if you don't mind, it'll take you to 30 seconds maybe to do that. But thank you very much. And if anybody has questions, I'll stay for as long as I'm allowed to. So
great. Well, we'll go on for maybe another 5 minutes. Drew, this is
Sure.
Fantastic.
Well, thank you very much. It's a real pleasure for me to be able to do it. I get to live my dream and help people at the same time. So it works out well for everybody.
I spend a lot of time up in the Thousand Islands, and I use your forecast to figure out what's going to happen up there. They really
good.
blend well together.
Oh, good.
We've got a question got a photo here to share.
Okay.
Let's see if that gets popped up. Mario? There we go.
Oh.
Now, that was taken by one of our members. In fact, the fellow who recruited you to come speak today, who's not here, unfortunately, Mart Hartzinger. He shot this from the west side of Lake Cayuga down in the south end across. What do you see there? Tell us what you see.
Yeah. So what we've got, and I think I actually have another picture somebody sent me of this exact same cloud and storm. So we've got an isolated rain shower. Basically, the cloud type is a cumulonimbus or a cumulus, and you can tell it's that because it's that white puffy type of cloud. And because you see all these sharp, really defined edges, you can tell that this cloud is actually growing. So it's in the process of developing right now. Towards the back side here, it's a little less defined and it's a little more wispy looking. That part of the cloud is probably decaying. And then the dark cloud base comes in from just the light, how it's reflecting. And then the really cool part about this picture, and I always love seeing this, is the curtain of rain that you see coming down. And if I remember correctly, assuming this was taken, I think it was last week, there could have been some hail with this storm cell as well. So yeah, that's kind of an overview of what we've got going on there.
Great. Thanks, Mario. Thank you. Go ahead.
So in your work, academic work, you studied a lot about public perception of weather forecasts and so on. My work is in public health. And throughout the pandemic, we found that quoting percentages, as you found, for people is a problematic thing to do. It's hard for a lot of people to understand them. And so we shifted instead of saying 90% of people will be experience this or that symptom or be benefited by the vaccine, we would instead say out of 100 people, 90 of them will be fully protected, 10 will not have as full of protection, and converting it to a more concrete number. In our use of weather forecasts, percentages have played into our thinking in terms of, well, how likely is it that there's going to be a rainstorm? So I wonder, first, one question is, have you given thought to converting to concrete numbers? And second, what other things have you learned about public perception of weather forecasts?
Sometimes when I'm talking one-on-one with somebody and it's, for a specific time, a specific location, then I'll go towards more of a concrete number. I'll say, there's like a 50-50 shot that you're going to get rain here. Sometimes I have farmers talking to me, trying to get their hay in. And so I'll use that sometimes in there. Online, since I'm covering such a big area, I find it a lot more useful to just describe what's going to happen. Today's a real good example. We've got rain showers coming in to some of the region, but not other parts. And so I was able to highlight those areas. And when I put the forecast through to like my app, and if you type in your zip code on my website, I was able to break down the different zones across the Finger Lakes that have those different chances. And it looks like the forecast is doing decently from what I see on I've got a big screen up on the side here. It's got all the current weather information. That's why I keep looking up there. So yeah, I think there is a place for it. I think it's more in the one-on-one setting as opposed to kind of a broad general forecast, at least from my experience. And part of that is with the weather, some people interpret 30% chance as 30% of the area will get it, or 30% of the time it will be raining, or out of 100 days, 30 of the days will have rain. So there's, three main different ways that people are going to interpret that. And so I just find it easier just to try to describe it. As for the other things that came out in that research project, people really were confused about watches and warnings and what exactly is what. And, that's something that I still hear all the time. I'll hear people, if a tornado watch gets issued, I'll see comments on Facebook like, oh, there's a tornado warning for all of New York State until 10 p.m. I was like, no, that would mean that all of New York State is getting a tornado from now until 10 p.m. And so that's not how it is. Precipitation type was also something that a lot of people didn't understand. I still remember one survey response said that sleet was rain falling at a steeper angle. And my meteorology majors buddies and I got a chuckle out of that one. So the difference between snow, sleet, freezing rain, snow is snow and rain is rain. Sleet is a snowflake that melts and then refreezes before it hits the ground, so it falls as an ice pellet. Freezing rain freezes into rain, but then doesn't refreeze until it's already on the surface and hits something cold. So people didn't understand that, and so every time there's one of those mixed precipitation events, I try to explain that to people. And just trying to get us, the other thing I was trying to do in that project is get a sense for, how accurate do people think meteorologists are? What areas can we improve on communicating better in, and things like that. And I surveyed the meteorology students as kind of like a control group to see how their answers were different. And there were some interesting things in that. Like, I think the meteorology students actually had less trust in their forecasts than the general public did, which seemed a bit backwards to me, but I thought they'd say, oh yeah, we're right all the time, but we're not. So
Sounds like
Yeah.
a typical professional group response to whatever their field is.
Yeah.
Yeah.
Drew,
Good.
I
Go
live
ahead.
on the east side of southern Cayuga Lake, and for probably 40 years, and we generally experience what we call a bubble in terms of weather coming in from the west and never quite gets to the other side.
Mhm.
Either thunderstorms or snowstorms. Obviously, this is sort of micro weather, and so what do you do about micro weather? There must be lots of other pockets all over the Finger Lakes.
Yes,
And-
there are. Yeah.
And how come nobody documents them? Nobody says, oh, you're in a micro climate, so it may be entirely different.
Well, I definitely see that all the time. I definitely have people telling me that all the time. And I also think I'm in one of those bubbles because we'll have a nice line of thunderstorms coming. And I don't know if it's because I'm a meteorologist or what, but they never seem to make it to Groton. They always split and go up to Moravia and down to Dryden and not do anything here. Except for when I go to my parents' house in Moravia and then the storms hit Groton. So it must just be me. But yeah, I mean, I'm not aware of any studies that have been done on this phenomenon. And, it's something pretty isolated to these areas of complex terrain, like the Finger Lakes. I don't think you're going to see this sort of thing out in Kansas where it's all just flat. And,
I have a summer place down in Cape May, New Jersey, which is pretty flat.
mhm.
There we have the Cape May bubble because of the Delaware Bay. And you can almost look at the amount of precipitation in the summer for the towns on the west side of the bay and compare the much greater than the towns on the east side of the bay. So
Yeah, definitely. Bodies of water have a huge impact on those sorts of things. I mean, so much of our weather is determined by the Great Lakes. And they have such a huge impact on what we get from day to day. I would love to do a study on, trying to document this phenomenon. It's definitely one of my biggest areas of interest right now. I haven't figured out a good way to do it methodically and scientifically yet, but it's definitely, I wouldn't even say it's in the back of my mind. It's like halfway up. So
Great. All righty. We're about running out of time here. Drew, if you could stick around for a couple of minutes, I got a couple of questions for you.
sure.
And one last thing, would you tell folks what you do with what your real day job is?
This is mostly my real day job. I
The other
do-
one.
dabble in a couple other things. First of all, ever since the pandemic, we homeschool our kids now. So, part of my day job is teaching math to 3 boys, which sometimes can be fun, sometimes not. I've been dabbling in some writing. One thing that I am hoping to do someday is to write a book on or actually probably a series of books, kind of like a weather history of the Finger Lakes region, highlighting some of the bigger events and talking about things that most people have forgotten, but, are still there in the record books. So, that might be a project coming down the line. But a lot of what I do, is kind of monitoring the weather and, when things start to get more intense, I'm there posting updates and stuff. So even when I'm
You
not
do
posting, I'm watching. So
doing anything with goats?
we used to have a soap business. We shut that down once we started homeschooling last year, but we do still have some goats. So we do have a little bit of a hobby farm going on the side, but not a full business like we did a couple of years ago.
Oh, great. Hey, let's give Drew a hand for a great learning opportunity today.
That's
Thank
right.
you. Thank you. so
Thank you
much.
all.
Thank you, Drew.
I love to talk about this stuff, so thank you.
Amen.